Hello, everybody. This is me. This is Keon. I am going to maybe first change the lighting. It's pretty bad. Okay, is that better? Hi. All right, so I'm gonna do a little. I'm gonna do a little vlog here. This is pretty weird. I just turned on the camera right away. I'm bored. I want to try something new. Um, I'm gonna talk about. What am I gonna talk about? I guess I'm gonna talk about the math that I'm excited to learn. Okay, the math I'm excited to learn. So I'm in grad school now. I'm doing my master's in math, and I am learning a lot of math. But the thing with math is that the more you learn, it kind of like never ends. You know what I mean? It just never ends. It just keeps on going. So the more you learn, the more you um, kind of like the scope gets bigger, right? So it's like when you first start out in math, it's kind of just like you have like a little bubble of math, right? Maybe you know some calculus, you know some algebra, whatever, just like a little bubble. But then the more you learn, kind of like the bubble grows, and it's like there's even more to learn the more you learn. So it's almost like exponential growth. It's crazy. It's crazy stuff. So uh yeah. So yeah, I like math. So I'm gonna talk about some of the subjects that I want to learn. Uh, and luckily, I have the textbooks here. So I have a big collection of textbooks, which is really nice. It's a very nice collection. And yeah, I have for a lot of these textbooks here is stuff that I haven't fully learned yet. Like I know some of the material, but I don't know all of it. So yeah, so there's a lot of textbooks here that um, I'm excited to one day get into more, right? So I guess I'll just go. Let's see. I don't know. This isn't planned. I just started recording this, so I'm gonna see what can I talk about first. Um, hmm. What should I guess right here. Um, actually, you know what? You know what? Maybe first I'll talk about this. I'll talk about. Okay, something dropped there. It's okay. Talk about this book. This is Abstract Algebra by Dummett and Foote. Um, I mean, well, actually, this is a textbook that I have gone through a lot of. I mean, this is like a this is a crazy textbook. This is like a iconic textbook for abstract algebra because it covers a lot of stuff. Like, I mean, look at this. It's like almost 1,000 pages. It's almost 1,000 pages long, and it basically just it covers a lot. It covers from like the start of abstract algebra all the way, and it goes really far with it as well. So right now, I'm learning what's called Galois theory from this textbook. I'm learning about fields and Galois theory, and that's been really cool. And so this is a really good textbook. I've been really enjoying learning from this. And there's a few things that there's some good stuff near the end of the book that I'm looking forward to learning from here. Let's see. There's some algebraic geometry stuff in here. Um, some number theory stuff. But I'm kind of getting to the end of this book, which kind of makes me sad a little bit because it's written really nicely. The explanations in that book is are like really clear, and it's one of those things too. It's like I feel like for me at least, when I have a new math textbook, um, you start to get used to that textbook, and then it becomes like it's familiar to you. It's like the way the authors write it. You start to get used to their writing style, so when you're done with that textbook and you have to go to some other author, it's kind of a jump, you know. So, but that one, Dummett and Foote, um, yeah, it's a good one, and I'm like almost done with it, but I still have a bit I want to learn from that. So, yeah. So that was just that. That was just there. Let's see what else. I mean, this one right here. Okay, so this is a introduction to homological algebra. Homological algebra. So this is a big book as well. I mean, there's a lot of stuff in here. And yeah, this stuff I'm really looking forward to learning this as well. So, I mean, the thing is, I don't know. I honestly, I just started recording. I don't really know what the audience for this video is. I guess I could, um, yeah, I don't know. I guess I'll try to, well, because I'm gonna try to explain what homological algebra really is, but that's kind of hard to explain. But essentially, this is kind of like a branch of algebra that's used in many different fields of math. From what I know, I mean, I don't know too much of it yet, but this one has a lot of connections. Like the kind of the techniques that you learn in this is kind of like very fundamental techniques that are used in all kinds of math, whether it be topology or number theory. Um, all kinds of math use the techniques of homological algebra. So it's something called homology and cohomology. Those are like the key terms that you learn about in that book. And yeah, those things are kind of used everywhere. So I'm kind of looking forward to learning it. Yeah, because it's kind of one of those things where it's used everywhere and like I know it's used everywhere, so I kind of want to start to actually learn it properly now. So yeah, I don't know when I'm going to learn this, but at some point soon, you know. Um, so far I've so far in terms of like the contents of this book, like I've learned some of it, but it's more just been like picking it up over time as I've learned other kinds of math where it just some of the concepts show up. Um, but yeah, that's homological algebra. Yeah. I guess I don't know, one more thing I could talk about. I could talk about this book here. This is this is a good one. This is algebraic topology. Algebraic topology. This subject is definitely pretty crazy. Um, so the thing is, topology is, I mean, it's kind of hard to explain any of these math concepts without using, jargon or using math language to explain it. But um, topology itself is kind of like you're studying geometry, but there's no distances involved. Um, so topology, I mean, in some sense, you could say that topology is the study of shapes or the study of spaces that no, it's the study of the property, it's the study of the properties of spaces in which those properties don't depend on rigid distances. Okay, if that makes any sense to you at all. I mean, one example of that is holes. So if an object has a hole in it, if you think of a donut has a hole in it, right? You can put your finger through the donut, it has a hole. So it turns out that the fact that that donut has a hole, that's actually a topological property of that donut shape. So that's actually not a geometric property. It's actually a topology idea, right? Like the reason it has a hole is something topological. So that would be an example of like a topological property. And so the study of topology is, like I said, it's the systematic study of those properties of shapes that don't depend on a geometric notion. So that's what topology is. And so there's a general study of topology that you could do. Um, and I did take a course in that kind of general topology. I did that last semester. But basically, this algebraic topology stuff, this is basically all about using the techniques of abstract algebra to study topology. And so it's basically the connection of algebra and topology kind of put together. And this is really hard stuff. Like this is some really difficult stuff. Basically, in my last semester, when I did take the topology course, at the very end of the term, we did a little bit of algebraic topology. So we kind of got um, an introduction to some of like the first ideas and first kind of constructions of algebraic topology. And it was pretty interesting, but that stuff was really, really hard. It was really hard because, in my opinion, what makes it so hard for me is that it really requires a lot of visualization kind of stuff, you need to visualize like spaces and these shapes in your mind. And what makes the visualization so hard is that these are not shapes that you can conceive of in real life. Sometimes you can, like the donut. The donut you can think of in real life. Like if you're studying, they call it the torus. So in topology, the donut is just called the torus. And so if you're studying the torus in topology, yes, you can visualize that as a real thing in your head, like a donut. But you can't always do that with some of the spaces that you're studying. Like there's all kinds of topological spaces that you can't just picture in your head. The most you can do is picture like little parts of it, but then you have to try to bring all those parts together in a certain way that makes sense mathematically. So it's just really hard. And if you open this textbook, you'll see that like there's just there's like a lot of pictures, a lot of pictures of stuff. Like look, it's like a bunch of, what is that? A bunch of holes. It's like a bunch of donuts. It's a bunch of weird stuff like that. It's like there's very crazy stuff here. Let's see what else other pictures I can find. I don't know, just like a bunch of stuff. It's yeah. So it's pretty hard stuff, and um, I don't know. Like I do want to learn it, but on one hand, I'm not like totally interested because of how much visualization it requires. Just because it actually, that kind of part is definitely trickier for me personally. Um, because like on the contrary, if you like right now I'm studying Galois theory. So Galois theory is a subject in uh, algebra, in abstract algebra. So and it's quite a purely algebraic type of subject. Of course, actually, I mean, if there's any mathematicians watching, I'm aware that Galois, like the ideas of Galois theory, extends beyond the initial algebraic kind of viewpoint. You can apply it to a lot of different areas in math that may be more kind of visual, but at least in the first time you're learning Galois theory, it's very algebraic, and so it's very like rigid. So pure algebra is very it's kind of like mechanical. It's kind of like rigid. There's not much visualization going on. And that's actually more comfortable for me to learn personally. It's like my mathematical comfort zone. So I think that's why I gravitate towards algebra as well. Um, but yeah, so that's Galois theory. So it's not as, visual as topology. So it's a little bit easier for me to learn. But anyway, I guess I'm just rambling now. But that was just a random video. That's just some math textbooks I have that I guess I wanted to talk about. So yeah, maybe I'll do more videos like this. I'm not sure. But yeah, thanks for watching. See ya.